Hi everyone, and welcome back. This is Alexander Lim, and welcome to AuthorStory. Our featured book for this episode, which you can check out by clicking on the Amazon link in the video description below, is Fire in the Sky, Cosmic Collisions, Killer Asteroids, and the Race to Defend Earth. Gordon Dillow is the author, and he has been a reporter, columnist, and war correspondent for more than 30 years, writing for such newspapers as the Orange County Register, the Los Angeles Times, and Los Angeles Herald-Examiner. So, Gordon, welcome to AuthorStory. Thank you very much for being here.
Well, thanks so much for having me, Alex.
Cool, you're welcome. So, Gordon, let's get on to this. So, you've covered a lot of issues as a reporter, and you've written 2 books other than Fire in the Sky on topics such as surgery and internal affairs. I really have to ask, were you always this curious about a lot of things when you were, when you were a kid or when you were younger?
Yeah, that's kind of what I liked about being a newspaper reporter. I mean, you weren't really an expert in anything, but you got to sort of delve into everything. So it was always kind of fun. Every day was different than the day before. So I spent 30 years doing it and enjoyed every day.
All right, cool. So, a lot of us, you got, we lose a sense of curiosity and sense of fascination as we grow older. Do you have any secrets on how to keep such a curiosity going?
Well, just if you start looking into something, you're going to find facts that you didn't know. And even at a relatively advanced age, there's kind of a joy in learning things that you didn't know before. For instance, in this case, I really hadn't done much science reporting previous to this book. You had mentioned I'd written books with a U.S. Navy trauma surgeon in Iraq, a book about an internal affairs chief for the NYPD. Did one with a FBI agent about bank robberies, but I'd never really done one about science. And then one morning at 4 a.m., I live in the Phoenix area in Arizona. I was having an early morning cup of coffee on my back porch, and it was still dark. It was, like I said, 4 o'clock, and all of a sudden the sky started lighting up with this sort of red, angry glow. I mean, it was like nothing I'd ever seen before, and it looked like high noon in hell. There was all of the saguaro cactuses were lighted up in this red light, and then all of a sudden, about far off to the northeast, there was an explosion. It was this explosion of white light that was brighter than the sun. And I thought, wow, what is this? I mean, it was sort of a end of the world kind of moment. And then the next day, NASA announced that what caused this phenomenon was a piece of space rock, an asteroid, that had entered Earth's atmosphere at about 40,000 miles an hour. And as it entered the atmosphere, it heated up, which caused this glow, and then it exploded. And the thing about it was, NASA announced that this asteroid was very small. It was about 5 feet wide, something like that. I mean, it's the size of a lazy boy recliner. And I started thinking, how does the space rock, that's small, create such an explosion, such a huge explosion? So I started looking into it, and the more I found out, the more fascinated I became, and the result was this book.
Wow, nice. So just to confirm again, when did this happen? When did this incident happen?
This was in 2016, in June of 2016.
All right, so that's about 3 years ago. Okay.
Yes.
All right, okay. Now, I'd just like to ask a little bit about something about writing, because you're a journalist, and I'm thinking, writing an article is different from writing a book. Was there much of a challenge for you, writing a book compared to being a journalist? Because I know you mentioned you've written 4 books now.
Yeah. Well, it's, excuse me. Basically, a book is a long article. It has a beginning, a middle, an end, and you try to make it as dramatic as you can while still getting across all the information. Now, obviously, a book takes a lot more time. I spent probably about a year on researching and writing, and then another 6 months or so on the editing process and that sort of thing. So it takes a long time, and unlike being a journalist, you find yourself concentrated on one subject. To the point where you can hardly think about anything else, which is a hardship on the people because you want to talk about asteroids all the time, and they're sort of interested, but not all the time.
Okay.
So it's it's a long process, but it's great fun. It's
Uh,
great fun.
okay.
Writing a book, there's a feeling of accomplishment, a feeling of satisfaction once it comes out, and then the hard part begins, which is trying to publicize the book.
Hmm. Okay. All right. Cool. Well, maybe we can help you out here.
I'm hoping so.
Yeah, definitely, definitely. Okay, so let's get on a little bit about the topic. Now, from what I understand, in the past, the old paradigm, there's in the old paradigms, the way people thought about, well, talking about creators here. How did people understand that these things came about?
Well, it's really only been in the past 2 centuries or so.
Hmm.
Excuse me, Alex. It's really only been in the past 2 centuries or so that we've even known that asteroids existed.
Okay,
Um,
okay,
they did, the telescopes before that simply weren't powerful enough to pick them up. And once they discovered that asteroids existed,
hmm.
they thought that almost all of them were in what's called sorry, Alex, I keep doing that.
No, no problem, no problem.
Well, once they found out that asteroids existed,
Hmm.
they thought that most of them were, pretty safely parked in orbit between Mars and Jupiter. In
Hmm.
other words, they just go around the sun, just like Earth does and Mars does and all the other planets.
Right.
The thing is that occasionally one of those asteroids kind of veers off that orbit and comes close to Earth.
Hmm.
And we call those near Earth objects or near Earth asteroids.
Right.
And over the past 20 years, as telescopes have gotten better and more sophisticated,
Hmm.
the astronomers have discovered about 20,000 asteroids of different sizes
Hmm.
that come close to Earth.
Wow. Okay.
And when we say close in space terms, that can be 1 million miles, or in some cases, it can be tens of thousands of miles.
Hmm.
And occasionally, they don't always just miss us. So, occasionally, one of them actually impacts Earth. Now, if they're
Right.
small enough, they'll burn up in the atmosphere, like the one that I witnessed in 2016.
Right.
Something like that happens somewhere on Earth, probably once a month,
Hmm.
something like that. But if they're bigger, if they're larger than a certain size, say over maybe 30 or 40 yards in wide,
Hmm.
they can make it through the atmosphere and hit the Earth, or they can make it far enough through the atmosphere that they explode
Okay.
with destructive power. And I think
Right.
you may remember back in 2013 there was an asteroid that it was about 60 feet wide that exploded over the Russian city of Chelyabinsk,
Hmm.
and the shock wave, it exploded with the force of about 30 Hiroshima atomic bombs,
Oh.
which is just a tremendous amount of power. And the shock wave from that spread out and it hit the city of Chelyabinsk and tore out windows and knocked down walls and that sort of stuff. And about 1,500 people were actually injured by this.
Hmm.
Amazingly, nobody was killed,
Hmm.
but it was kind of a wake-up call to people that asteroid impacts aren't just the stuff of Hollywood movies or
Right.
science
Right.
fiction. They actually happen, and they'll happen again. It's not a question of if we're going to get hit by an asteroid at some point. It's a
Hmm.
question of when. It could be 100 years from now, or it could be next Tuesday. Right now, we just don't know.
All right. Of course. I mean, with 20,000 things zipping around, possibly, in close or near Earth orbit. I mean, that's the probability is very high. It's inevitable.
And those are just the ones we know about. There's tens of thousands more that haven't been discovered yet. So we have no idea where they are or where they're going.
Mm. Okay. Right. So, how big are these things? I mean, are we talking like things the size of the moon, or are we talking about things like what you noticed, like the size of a lazy boy? On the average, how
Um,
big are these things?
Much smaller than the moon. The biggest asteroid out there, which is in the main asteroid belt and poses no danger to us, is Asteroid Ceres, which is
Okay.
about 600 miles wide. But
Mm-hmm.
they come in all sizes. Some are a yard wide. Some can be 20 miles wide. Now, the ones that we really have to worry about, because the smaller they are, the more of them there are. In
Mm-hmm.
other words, you have a few big ones, you have a lesser number of somewhat, or a greater number of somewhat smaller ones, and on down the line. So most of the asteroids out there that we need to worry about are, of the 50-yard wide, 150-yard wide, that sort of size. Now, of those, again, there's tens and tens of thousands of these things out, but they can still do damage.
Okay, and from what I understand, like asteroids, different kinds of asteroids are made of different kind of materials, right? I mean, it would be logical then that the denser asteroids would pose more of a danger to us than, say, less dense asteroids.
Exactly. Metallic asteroids that are made mostly of metals,
Hmm.
they're more likely to be able to penetrate our atmosphere and hit the Earth.
Hmm.
Stony, rocky asteroids, they're more likely to break up in the atmosphere. Fortunately, there's the percentage of metallic asteroids to stony asteroids or rocky asteroids. There's a smaller number of metallic ones, but they, like you say, they do come in all shapes and sizes. I mean, there are asteroids out there in the main belt that are shaped like dog bones, or they're shaped like ladies' shoes or
Okay.
potatoes. Potatoes is always kind of a popular shape for asteroids. In
Okay.
fact, in The Empire Strikes Back, when Han Solo takes the ship into the asteroid field,
Right. Right.
uh, the special effects guys actually use some russet potatoes to
Okay.
fill in for asteroids.
Okay. All right. Interesting. Interesting. And these asteroids, the ones that do go on near Earth orbits, do these orbit in, say, the Earth's orbit as it goes around the sun, or do these things come from far away? Like out there in the orbit of Pluto or something like that.
No, they're kind of they orbit the sun just like the Earth does.
Okay.
Some of them take like maybe 4 years to orbit the sun as opposed to the year that it takes Earth.
Hmm.
But they're all kind of, think of it as sort of a NASCAR racetrack where you
Okay.
have all these asteroids circling around, circling around, circling around on the track. And then every now and then one of them veers off into the infield
Hmm.
and starts cutting donuts in the infield, and Earth is in the infield. So those are the ones that come closest to us. And I mentioned that some of them come really close. In 2029, on a Friday the 13th, no less, there's
Okay.
an asteroid. There's an asteroid called Apophis
Hmm.
um, that's about 1,000 feet wide.
Hmm.
That's the people at NASA predicted it's going to come within 19,000 miles of the Earth's surface.
Whoa.
Now, 19,000 miles is closer than the satellite that brings me my dish TV.
Hmm.
So that gives you an idea of just how close that thing is going to come.
All right. So 19,000 miles. I'd like to talk a little bit about scale here, because I mean, you're throwing out numbers here like 19,000 miles, 20,000 miles. Uh, you did give a little bit of an idea, give a bit of an idea of how far 19,000 miles is. But how does compare to, say, like distance from the moon to the Earth, or the moon to, say, the Earth to the International Space Station, something like that?
Yeah. Well, the from the Earth to the Moon is about 240,000 miles.
Okay.
So 19,000 miles is much closer than the Moon.
All right.
And proportionally, it's sort of like when this asteroid misses us by 19,000 miles. Proportionally, it's sort of like a bullet missing your head by 16 inches. Now,
Okay.
it's not going to kill you. It's not even going to hurt you.
Mm-hmm.
But if you've got any sense at all, it's gonna attract your attention.
Definitely, definitely. Okay, all right, I got that. Okay. So before we continue, can you? I'd like some definition of terms here, if it's okay with you, Gordon, because
Sure.
a lot of folks can get confused with all these terms. Like we're talking about terms like meteor, asteroid, comet, and all that stuff. So can you differentiate amongst these, just for our benefit?
Sure. Well, when people talk about meteors, they're actually talking about the streak of light that's caused when a very small particle of space rock flies through the atmosphere at tremendous speed, and that usually they call it friction with the atmosphere. It's a little more complicated than that, but it
Right.
lights up to these tremendous temperatures, and it leaves a streak of light in the sky,
Uh huh.
and that's technically what a meteor is. And you can go out on any cloudless night and look up in the sky for a while, and chances are you're going to see a meteor.
Mm-hmm.
Now, if a space rock makes it through the atmosphere and either explodes or it just punches right through the atmosphere and it hits the ground, that's a meteorite.
Okay.
And yeah, that's what people collect and what people trade and what people search for. There's a whole kind of sub world of people who are totally into meteorites and they just love these things.
Right.
Now, an asteroid again is a space rock generally, these definitions aren't hard and fast. So
Okay.
scientists and astronomers they just can't seem to get together on this thing. But generally speaking, an asteroid is a space body that's made of rock or metal that ranges from maybe a yard wide, 2 yards wide, up to, like I say, hundreds of miles wide.
Right.
Now, a comet is a little bit different.
Mm-hmm.
Comets exist way, way out at the edge of the solar system.
Right.
And they also orbit the sun,
Right.
but they're made up of ice and dust and little pieces of rock.
Mm-hmm.
And as their orbits take them closer to the sun, the ice in the comet starts to gasify. It turns into gas, and that's what makes these enormous heads of comets and long tails of comets that reflect sunlight.
Right.
So
Right.
when we see those, like Halley's Comet, or there's Hale-Bopp or whatever, we can see those millions of miles with the naked eye. We can see those millions of miles away in space, and they're really spectacular. They're kind of the glamour boys of the solar system. Asteroids, you can't really see them without a telescope. Very rarely can you see one of the largest ones with the naked eye. So they've been out there. They're out there circling around, but we just don't see them. If we could see them, if somehow we can mount a powerful light on every asteroid that comes close to Earth,
Right.
you'd look up at the night sky and it would look like the 4th of July.
Wow. So there's that many of those things floating around.
Oh yeah, as I say, tens and tens of thousands of them, large and small, mostly small ones, but also some large ones.
Right. Well, I guess it's some consolation that most of them are small, because geez.
Yeah. And most people, when they think of asteroids, they think about the dinosaurs.
Right. Right.
And there's some controversy about it, but I think most scientists today that agree, what gave the final send-off to the dinosaurs 65 million years ago was the impact of an asteroid about 6 miles wide.
Mm-hmm.
And you wouldn't think that something that relatively small, remember, Earth is about 8,000 miles in diameter.
Right.
And this asteroid that hit it was 6 miles. So the ratio, it's sort of like, throwing a piece of pea gravel at a giant boulder.
Mm-hmm.
The thing is, these asteroids, they're moving so fast and they pack so much kinetic energy that when they hit the Earth, like this one did 65 million years ago, it sends up it creates a huge crater. The crater that was created when the dinosaurs were wiped out was tens of miles deep, 100 miles across. It was just huge. And it sent up this cloud of dust and gases and kind of fiery material that set wildfires. And this cloud enshrouded the Earth and blocked out the sun, and that's what eventually killed the dinosaurs. The plants died, and then the herbivorous dinosaurs died, and when they died, the carnivorous dinosaurs died.
Right.
This is the theory. No offense to people who don't necessarily believe in evolution, but this is the prevailing theory.
Right.
And actually, that turned out to be a good day for us, meaning we humans.
Yep.
Because while the asteroid impact wiped out about 3/4 of all the species on Earth 65 million years ago, there were these kind of small rat-like mammals that managed to survive. They were burrowing creatures, so they kind of hid in their holes and managed to survive the global cooling and the fires and all that was caused by the asteroid impact.
Right.
And when they crawled out of their holes, the dinosaurs were gone, so they didn't have to worry about getting eaten or stepped on anymore.
Right.
And eventually, through evolution, they became us. So that day the asteroid hit 65 million years ago was the dinosaurs' worst day, but in a way it was our best day, because if it hadn't happened, who knows, maybe we wouldn't be here.
Good point. That's nature does fill in any what's that? Any gaps, any vacuum with new creatures.
Yes, it does.
Yeah, cool. All right. So I'd like to talk a little bit about the meteors, like what you witnessed, the explosion in the atmosphere. How often do these explosions occur? I mean, from what I understand, most asteroids they just burn up, with just a puff or something like that. Very few of them explode the way the meteor notice did.
Yeah, yeah. It depends on size and composition,
Mhm.
as we talked about before. If they're small enough, they're just gonna kind of burn up completely,
Right.
and you'll have a meteor, a streak of light, called the meteor. If they're big enough, by the time they get deeper into the atmosphere, the pressure that's working on them is just tremendous. The internal pressure, and it causes them to, explode with powerful force. I
Right.
mean, you wouldn't think that passing through air would really be able to, exert such a force. But
Mhm.
I think all of us have stuck our arm out the window from a car that's going 60 miles an hour,
Right. Right.
and you can feel the pressure of that air on your arm. Now imagine if your car was going 40,000 miles an hour.
Uh-huh.
I mean, it would tear your arm off, of course, but it's all an asteroid hitting the atmosphere at that kind of speed. It's almost like running into concrete. It's the air resistance is just so tremendous,
Right.
and the one I saw in 2016, again, not very unusual. It was unusual in the sense that it happened near a populated area, and a lot of people saw it. It was caught
Right.
on all sorts of dash cams and cell phones and surveillance cameras and that sort of thing.
Right.
But they happen pretty routinely. Back in December of 2018, there was an asteroid I think it was about 20 feet wide that came through the atmosphere and exploded up in the atmosphere above the Bering Sea.
Mm-hmm.
And it exploded with the force of about 10 Hiroshima atomic bombs.
Mm-hmm.
That's how much power it dissipated,
Whoa.
into the atmosphere.
Right.
And the thing was, nobody even noticed
Uh-huh.
until a couple months later. Some scientists were going through some data,
Uh-huh.
about disturbances and some Earth monitoring satellite images from NASA,
Right.
and they saw this thing,
Mm-hmm.
and nobody had even noticed because it's such a remote area and it was clouded over. So these things happen all around us without us even knowing about it sometimes.
Okay. Okay. All right. So that's a pretty that for me that's something that screams something like be something to be cautious about. I mean,
Yeah,
these things release a lot of energy.
absolutely, absolutely. And in my book, I'm not trying to scare people or be, you know, say, the end is nigh, or
Right. Right.
have a doomsday scenario.
Yeah.
I'm just sort of delving into a subject that I find fascinating,
Mm-hmm.
and that we're learning more about every day. And it's actually possible
Mm-hmm.
for us to stop an incoming asteroid if it's small enough, and if we get enough warning.
Mm-hmm.
There are ways that we can actually deflect it so it wouldn't hit Earth.
Mm-hmm.
And we wouldn't have to call Bruce Willis. I mean, there's techniques that they have right now that actually NASA is about to test in real space conditions,
Mm-hmm.
where we could deflect an asteroid that seemed to be headed, on a certain course for Earth.
Right. Okay. So what are some of these techniques? I mean, if you're allowed to talk about them, that is.
Yeah, yeah. They talk about these very openly. Every couple of years, there's a planetary defense conference
Uh-huh.
that's hosted by NASA and the international astronautical groups and that sort of thing, where scientists from around the world get together and try to figure out, hey, okay, if we spot an asteroid coming toward us, what are we going to do?
Mm-hmm.
Now, there's a couple ways that are kind of considered the most likely. Now,
Okay.
one is to detonate a nuclear device
Okay.
while the asteroid is still millions and millions of miles away from Earth.
Uh-huh.
And the idea there isn't to blow it up. It isn't to blow it into little pieces.
Mm-hmm.
It's just to exert enough force to nudge it a little bit out of its orbit,
Mm-hmm.
so that by the time it gets to its expected rendezvous point with Earth,
Right.
Earth will already have moved on in its orbit around the sun, and the asteroid will miss us.
Oh, okay.
Now, the problem with that is there's a lot of international space treaties concerning militarization of space.
Right.
A lot of people, they get kind of worried about the idea of sending nukes into space.
Right.
They're afraid that, oh, sure, we'll send them up there to, with the purpose of deflecting an asteroid, and then, some evil actor will use them, for military purposes or something.
Right.
So the other option that they're talking about now is basically cannonball technology.
Okay.
The idea is you set up an unmanned spacecraft and you ram it into the asteroid.
Okay.
But
Hello, Gordon. Hang on a sec. The signal's breaking up a little here. Hang on a sec.
Okay.
Okay. All right. Okay. Can you hear me now?
Yeah.
All right. Okay. So
Can you
sorry.
hear me all right?
Yeah, I can hear you. So can
Okay.
you just repeat the cannonball
Sure.
method?
Yeah. The idea is to send up an unmanned spacecraft with a payload of heavy metal, maybe 1,000 pounds, 2,000 pounds, something like that, and ram it into the asteroid more or less head on.
Okay.
And the idea isn't to destroy the asteroid or to break it apart. It's to slow it down just by the tiniest little bit. And if you can slow it down by just a fraction of an inch per hour, by the time it reaches the rendezvous point with Earth, again, Earth will have moved on in its orbit around the Earth. It's sort of like if you're in a car and you're approaching a railroad crossing, and there's a train coming down the track several miles away. And if the car and the train maintain their same speed, they're going to hit the railroad crossing at the same time, and so long car. The car is going to be destroyed.
Right.
But if you can slow down the train by just a fraction of a mile per hour, by the time it gets to the railroad crossing, your car has already passed through, and the asteroid or the train will safely pass by behind you. So that's the theory behind it. And actually, 21, NASA is going to launch a mission called the DART mission, the Double Asteroid Direction Test. And it's a test mission against a non-threatening asteroid to see if this, what they call it, the kinetic impactor method, the cannonball method.
Right.
They're going to ram a spacecraft into a small asteroid and see if they can actually deflect it, from its orbit. So this isn't science fiction. This is actually happening right now.
Well, I'm definitely going to look out for that. I mean, that's definitely something interesting. It's definitely something new.
Oh, it's going to be a great story.
Oh yeah, I'm sure. I suppose you'll be covering it.
Well, I hope so, in one form or another. I talk about it in my book, but I'd really like to kind of watch it as it unfolds. It's a several year mission. It takes a long time for a spacecraft to get from Earth to out to the asteroid, but it's going to be fascinating to follow.
Right. Oh, definitely. Okay, cool. Okay, Gordon. I mean, this is an interesting topic, but we're almost out of time in this interview. So, in the last couple of minutes or so, are there any last words of wisdom you'd like to share, maybe to inspire listeners, or maybe even make them a little bit more curious about what's going on here?
Well, what you don't understand is that this is all new. This until the past 10 or 20 years. There shouldn't be more about asteroid impacts. It shouldn't vacation plans or anything like that. They should be a little leery of some of the stories you see in the tabloids or here on the internet of, asteroid impact Earth in 2029, that sort of thing.
Right.
But they should look into it and realize that around the world, serious people, serious men and women, are addressing it. It may not help us. It may not, save any place on Earth, but maybe our grandchildren or our great-grandchildren. Because someday, again, it's inevitable. It's not a question of if an asteroid is going to hit Earth. It's a question of when.
Right.
And we should really be prepared for that. And we can do that right now if we just put the resources into tracking these asteroids and figuring out where they're going. And in the process, we learn a lot about our solar system and where we fit in the universe.
Right. Okay, well, yeah, well, a great words of wisdom right there. I mean, this is still an ongoing process. It's been around since the Earth began, and it's still going to be around for another what 4.5 billion years. So yeah.
Well, we think so. Uh, nobody's giving me a schedule on that, but that
All right.
sounds all right.
All right. Okay. Cool. Okay then. The book is Fire in the Sky: Cosmic Collisions, Killer Asteroids, and the Race to Defend Earth. The authors are guest Gordon Dillow, and you can find his book on Amazon. So, Gordon, thank you very much for being an author story. Thank you very much for talking about this interesting and rather fascinating topic.
It was my pleasure, Alex. Thank you.
You're welcome. So, everyone, check out Fire in the Sky and also be sure to subscribe to our channel to check out the awesome authors and books we've already covered, as well as the ones we'll speak about in the future. So, see you guys next time on Author Story, where we speak to another great author about another fantastic book.